Good afternoon, everyone. Hello. Thanks, everyone, for joining today. Welcome to the Beyond Horizon knowledge sharing sessions, where we bring external perspectives. And we have a really renowned speaker today. I invite Sunit Sinha, head of DNA DC, to kickstart the session.
Good afternoon, everyone. A very warm welcome from my side for this very special session of Beyond Horizon. I think this is an amazing initiative, yeah, where we get to hear from some of the inspiring mind from different fields who have probably pushed the boundary of what's possible. Today, we are very honored and privileged to have someone with us who has been a legend of Indian space science, someone who is fondly called the Moon Man of India, Padma Shri Dr. Mylswamy Annadurai. A huge round of applause for him. So welcome and very happy to have you here. He doesn't need much introduction. I mean, anybody who's following Indian space science for some time would know what he has achieved. So over 30 years with ISRO, he has been instrumental and driving force for some of the most iconic space mission we have had lately, namely Chandrayaan-1 and Mangalyaan. So I know for sure every one of you are very much aware of how much it changed the way Indian space science was looked all around the world. And we are very proud of what we have achieved. And he's the one who really drove those projects. I mean, not only that one, I mean, he led thousands of engineers to drive almost 60 satellites, if I'm not wrong. He has been representing us to many international forums, and he has been known as a very tireless advocate of resilience, innovation, of learning. I mean, you know, for the work he has achieved, he has numerous international and national awards. But what's really separates him from others is the prestigious Padma Shri Award he got for 2016 for his contribution to science and technology. So we often say, yeah, that come on, it's not a rocket science. For him, it was, and he made it look very easy. So we are very privileged to have you here, sir. And please join me in welcoming Dr. Annadurai. Have yours. Thank you.
Thank you.
All yours.
Yeah. Okay. Yeah. Good afternoon, all. Thank you for giving me this opportunity today to be here by the DC Varsity team. The topic beyond horizon. Say when you stand wherever it is, you are seeing in front of you the horizon. But you can see beyond that two ways. Keeping alive in environment, if you grow up or if you move forward. Correct, no? That means your growth and moving forward will take you beyond the horizon, which previously what it was. So that when we are talking about here, with another way of mission possible, innovating with purpose and precision. So this is how we can connect these things while still we are moving forward and looking beyond the horizon. With my thing with respect to space and even the beyond space during my life journey, I'm trying to cover up in some way. So when you talk about precision and purpose, it translates something like this. When you talk about precision technology and humanities in satellites. Okay, in engineering paradigm, if you look at there, any product you want to make is one way we have to design, come out with the drawing, electrical, mechanical things, integrate it, and do your testing, and then you put it in the field. But when coming to the satellite, there is something specific because you look at here when we're talking about the satellite around a planetary body you have to move. So when we are standing here, this Mother Earth is the habitable planet. So we are reasonably good when we are there. Environment is so conducive. We can stay. So we even electronics and mechanical equipment also reasonably good environment. But when you go to the space, environment is different. And again, to take it to the space, you cannot have the mass is a premium. You should be as small as mass and as small as the volume, and power also should be as optimum as to do. But beyond this, its reliability is all the more important. You cannot take back and correct it. So you see reliability also equally important there. So keeping that paradigm there, many things are keep coming down, and finally assemble, integrate, and do. And while operating, whatever we're talking about today, the digital twins, I think is a part and parcel of the satellite operations is concerned. But beyond this, what separates this domain going forward? Yeah, is the system engineering and the team building and the leadership. In some form or other, it separates beyond the normal engineering systems to this. Okay, that's why when we talk about it's not rocket science. What we're talking about here, because the many intricate things have to work together reliably, and it has to work first time correctly. I think this to make it to happen, but finally it's only the humans only they're making that, but the human paradigm is getting connected by a proper system engineering, team building, and the leadership. I think this is the bottom line of the whole gamut of thing when you're talking about the missions is concerned. But we're coming to the specific. Okay, so you cannot philosophy. Coming to the specific. Now I'm talking about the project director of Chandrayaan-1. There is a project report. Yes, India can do within that budget, within the technical capabilities, going to the moon. I think India was proposing nearly 30-40 years gap of the last mission to the moon. I think that is the Chandrayaan project. One of the reason being to enthusiast the people within the organization, to retain the pools within the organization, and also to attract the pools from outside. One of the reasons why this mission was identified is why so many years back it has to go is because mission to the moon probably will be able to enthusiast the people within the organization, because that's the time frame when we're talking about that. IT was booming, and ISRO was struggling to retain the people within the organization. ISRO also struggling to attract the new talents from outside. At this point of time, motivating force is called for, and it was called about that project. And notwithstanding that being going to government of India, so we cannot have a huge budget. You cannot have our within technical capabilities you do. So project report is a reasonably good, reliable project report here written. But with that project, if it go, we also become a also run case, possibly. Okay, so nearly 70-80 missions have gone to the moon, and 30-40 years have not gone to the moon because moon was declared barren. And you're also going to tell same thing only. Okay, that means something else you should do beyond the project report. What is that? Okay, and the thinking came is slightly different way. Is it possible to have an innovative approach? What is that approach? Okay, that innovative approach was initially a modest satellite. We had the remote sensing missions, we get the communication mission, putting the things together, we can go to the moon, and this mission can do a remote sensing of the whole moon, and we can look back what moon contains. Probably this technically is feasible using a PSLV itself. But in case if you discover something which people have not discovered 30-40 years back, because during the 30-40 years, instrumentation has become much better. So possibly we may see a better thing. Over and above that, our plan is to see the whole moon better way, rather than isolated one place to see. So when that way we see, even if you find something discovered, if somebody else, some other instrument from some other country also part of our mission, there is a possibility you will have acknowledgement of this. You will have an acceptance of what you have discovered. Okay. With that context, when we thought about whether we can go for international participation, the first change management on the paper itself before starting the thing is came. And that brought in so many organizations outside India, starting from NASA, the JAXA, European Space Agency, Max Planck Institute, German, like that many organizations, they offered their instrument, nearly 20 instrument came. But originally our plan was to carry one instrument probably in addition to our instrument planned there. But when you're looking at all these instruments, and some of the personal calls came from some of the people who of the planetary science, then I thought somehow I should carry more instrument, especially two NASA instrument. But two NASA alone we cannot carry. It calls for other things also. So that way we have gone through a lot more iteration, and we identified this mission satellite configuration slightly different way than this, keeping our resources with all the optimization of engineering optimization, we are able to come out there. So then it was projected in a international forum, wherein this is the our mission configuration in which ISRO is planning to go in 2008. I think this was put forward, and Dr. Kalam was the chief guest of the international conference, and he was the president of India also that time. Okay, then he called and told us, your mission is okay, everything is okay, but there is something is lacking. One more change requirement came from none other than Dr. Kalam. Okay, that is that requirement is your plan is to go to the moon and go around the moon for 100 kilometers around the moon, look for the what moon contains. Probably we discover and all, but in spite of all these things, somehow you have to make sure that Indian tricolor national flag is placed in the moon. First mission itself. This I told this is a technically very tall order requirement, because just a thumb rule, how much amount of fuel you have to spend to take from Earth to the moon, similar amount of fuel you have to spend, the same thing you have to bring back to the bring down. So, but now we already have so much optimization you have done, and 5-6 instruments of ours, 5-6 instruments of foreign countries you have taken, with all things putting together, it's going to be a tall order requirement to meet. But somehow, if he told you, somehow you meet this requirement. This calls for a lot of iteration within the organization. Okay, a lot of iteration in the drawing board itself. You look at here, the original configuration, starting from there, we changed it with the fire instrument came. But now, to make that to happen, we cannot undo what you have done. We don't want to undo that rather than, but keeping all the instruments same, how to make it this first mission itself, along with the tricolor flag to go, we brought back an idea of a piggyback system. Okay, that means go all the way to the moon and you throw the instrument down. That can go with the tricolor flag and land on the moon. But remaining lifetime, this satellite can work on that. In principle, okay. But keeping all the constraints same within the PSLV, within the schedule, within the budget, with all the things putting together to make it calls for a lot of iteration. That's what first biographer I told. Okay, you look at there. You have to do a lot more things today can consider beyond engineering drawing. The iterations have done. Okay, the field of view clearances, easy access to be there, replace, repair, quality check for component, many things you have to do. So this all these iterations called for lot of corrections to the models in various ways. Finally, we arrived at a satellite configuration, which was totally different from the textbook. Okay, it's not only the new satellite we are making, and the first our time such a sophisticated way, almost all the instruments keeping it outside, and within the PSLV capability we have changed. That means the whole thing from that to this it got changed. Everything as a team, and by this time you look at here when I tell the team, there is a team in the west coast of US, east coast of US, the whole of Europe, Japan, Indian labs. You just think about that. Okay, 24/7, everybody at work. Okay, at any time you look at here, this I'm talking about 2004, 22 years back. Okay, many of you were kids could have been by that time. Okay, and that is the time we are talking about. The whole thing is happening in a way which we are not even meeting, because we cannot go keep flying back and forth. Our budget is so much crunch. You cannot afford to have a tours. You have to sitting it there. You have to do it. I think many things happened there, and within this thing we should do. I think we have realized the mission. This mission, believe me, got 2 international awards for the design of the satellite alone. Okay, leaving alone the whatever we got it subsequent. So then this, but you cannot go to the moon with a PSLV with additional this mass all put together. It calls for a totally innovative approach of PSLV can launch a 500 kg satellite in an orbit of 22,000 kilometer to 200 kilometer, along with the required fuel of another 800 kg fuel. So that means 1300 kg system, it can be put only that much, but you have to go all the way to there. So incrementally improve the orbit and use the slingshot effect of the satellite Earth also, and put the gravity pull also there, and such that you go all the way to the moon. And after reaching 100 kilometer orbit, then you orient it and throw that small mass impact probe, whatever I told, and that will keep falling towards the surface of the Earth. along with the triangular flag as Kalam wanted. But it is not just passive mass. It has carried another 3 instruments, one imaging camera, one altimeter, one mass spectrometer. The mass spectrometer will try to sniff through the, if atmosphere is there in the moon, it will sniff through the mass. But nobody believed atmosphere on the moon. But fortunately, unfortunately, we believed. Okay, not we believed, we expected, because something is there, it has to come out of the moon. Gravity being less, it can keep coming out. So that atmosphere possibility there is told. But up to from 100 kilometer when we are falling, up to 70 kilometer, we didn't see anything. 70 kilometer onwards, we started seeing a peak of the mass spectrometer, mass number 18. You know, hydrogen mass number 1, oxygen mass number 16, 2 hydrogen and 1 oxygen makes 18. So that 18 indicates what presence of water vapor in the so-called tenuous atmosphere of the moon. From where the water could have been there, the water could have been come from the surface of the moon. When we keep falling up, this peak was keep going up and up and up. So in 2008, November 14, when Kalam was standing behind, I could see the peak of water presence on that there. Okay, this is the idea, whatever Kalam told change requirement. The change requirement was really a challenging requirement, but the challenging requirement gave us an opportunity to discover water on the moon. Okay, that's what happened there. So, but when we're talking about here, the precision in which we are supposed to do is another term we will look at here. Leaving alone the engineering way, how you arrive at the system. We have the PSLV on to launch slowly increase orbit. So it puts an orbit of 22,000 kilometers. You have to gradually you have to reach, go for this orbit. Okay, you look at here how much of additional velocity you have to give using your autonomy system, other thing is something like this coming. Here, when you look at here, this 1 meters per second, if you go, it will go from here to here. So this translates into 1 centimeter per second velocity around 62 kilometers. Okay, that means even if you make 5 centimeters per second error, you will either you go away from the moon or you will hit the moon, not happen. Okay, that means that is the amount of precision what is called for. Towards that, you brought in an autonomy. Okay, this is what autonomy came there, because we cannot go and stop it there. So autonomy was built in there. So like a smart car, the smart satellite has to start and stop. Okay, that way we brought in accelerometers and other things with their exceptionally good co-utility. So that way, autonomy it starts the steering and it stops it such that it will not make an error more than few millimeters per second. Okay, I think that is the thing it is called for. Talking about precision point of view. Now, having gone over that, first we have seen water vapors, but we have to quantify where the water. Okay, so then when we have discovered this, America woke up. Okay, they launched another satellite after 1 year, our launch is concerned, and that satellite is called LRO. Okay, Lunar Recurrence Orbiter. Now they come out with an idea: why can't we work together such that they give there is a synthetic aperture radar, so that will give the signal to the ground, to the moon, and we can pick it up from ours. We can send the signal. They can do that. Yeah, first ever time. 2 such satellite working in synchronously called for such a precision, okay, such that one signal is picked up from somebody, other signal is picked up from somebody, for what? To look at the moon where the sunlight is not falling, because normal remote sensing calls for the sunlight. From there only reflected thing you can see that. But what is happening is even if water is there, sunlight itself will vaporize the water. So water in the form of wherever sunlight is there, you cannot see the water. But if water is there, it probably maybe there are some of the regions where sunlight is not seen for the millions of years, something called polar regions. Polar region sunlight is not cannot fall, and there are big craters like that. Big craters are there. There sunlight never goes. So this water, even if it comes and keeps jumping, it will go and settle in the form of ice. But to understand what is the ice, it calls for a very innovative experiment. So this calls for a very good precision. So precision and engineering putting together, we are able to work together, and we have seen abundance of water for few meters of depth polar ice. Okay, first ever time anybody has seen that is happened there. Along with this, it's happened there. So this is then we arrive at the water map. Okay, you look at there. These are all the places originally people have landed. Water is not there even today now. But these are all the people have not landed. That place, the remote sensing, whatever you have seen is there. And into the poles, looking at there, that these are the green regions where we have seen the presence of water in the form of ice. We could see this. So the success story is keep moving forward. And 2009, then we thought of going for the Chandrayaan 2 also. 2009 work, we are going full swing. But this is not, life is not as smooth as possible. And 2009, 29th August, Chandrayaan 1 had a communication system failure. So we did a lot of optimization we have done. In the bargain, something happened, and this system, Chandrayaan 1 orbiter has failed. We are working it with Chandrayaan 2, make it faster like that. Then ISRO, we are ready to Chandrayaan 2 orbiter also in January 2011. But Russia, who was our partner by the time, he wanted to make a modification Chandrayaan 2 orbiter. That makes, that modification, whatever you're asking, makes our hardware, whatever is ready to fly to moon, cannot be used. Okay, this is the situation we got it now. So the team is becoming totally on and off. What way to go, what way to motivate the team is totally confusing situation. Just to think about this. If you are in this position, what would have been your response? You are on top of the moon and you are ready to go there. Now everything is getting grounded. Just to think about. I go option A, B, C. A or B or C? Please. Huh? C. Find an alternative solution. What is the alternative? Huh? What is the alternative? Elsewhere, people use to dump the hardware also because you can afford to do it because Government of India organization, your partner is telling you to change. Yes, I have to change. I will need some more money, some more budget, some more schedule. They can ask. I could have asked like any other Government of India organization. We didn't want to take that. Or else wait until the lander and rover. They are told to match for our level, and also you can write. That will require another 6-7 years. But for that, you need another budget. But find an alternative solution is okay. But what is the alternative solution? Okay, that solution comes from that dot. Are you able to see this dot? What is this? Not only this is a golden opportunity. Looking at Mars. Is it possible to go to Mars using this hardware? Instead of dumping there, is it possible to go to the Mars? That is the story of Mangalyaan. But it cannot simply take off. Okay, you are at the crossroad there. Just I'm simulating a crossroad where I am standing there. Our Chandrayaan own experience told within a year, satellite failed. You made a hardware, now you launch it, go to the itself will take 9-10 months. Okay, whether this hardware will survive or not, question mark. And elsewhere also, for the Mars mission experience, no country succeeded the first attempt. No country succeeded first attempt. In US, it was 5th attempt. Russia was in 9th attempt. China had to succeed. Japan had to succeed. Now, you made a hardware which originally supposed to go to the moon. Now you want to send to Mars. What is the chance of success? Team asks. Team is asking. Okay. Now the team is asking, what is this? What is this? So then, obviously, what you should do is C, you should go. Drop the mission and keep quiet. But if I kept quiet, I would not have standing here. Correct, now? Then what really happens? Say, look at here. A tells longer problem. B tells this is a problem. Is it possible to negate both A and B? Is it possible to negate A and B? A plus B is a problem. Minus of A plus B. That means that experience tells me something, but you correct it, that's negation. This experience tells 31 missions failed. So negate it, 31 way of avoiding failure possible. By the time there are 31 missions failed. The 31 mission why failed, you understand, I have the way to make a better mission there. I think putting together, we made this. Why can't we make the mission? This is the argument we put. We went ahead with all these iterations point of view. I have to go over circling. Not only the team, even the policymakers, government, you cannot simply decide now. Government of India organization, you cannot decide also. You have to subordinates, you have to convince, Not only have convinced the superiors. Yes, we have done. And what we told is same as what we had done Chandrayaan-1, same PSLV. This hardware supposed to go to moon same way. Everything remains same except the last maneuver when we do, you do slightly more than whatever you had Chandrayaan-1, such that it's taken away from the gravity of the Earth. Once you've taken away the gravity of Earth, Sun will take over. Okay, at the free of cost, not even the auto cost. Somebody told auto cost, not even auto, the free of cost. It flies like Earth is going around the Sun, Mars is going around the Sun, this Mongolian also go around the Sun. But you should create velocity, particular correct time, particular velocity, particular direction. Direction, quantum of velocity, time. This you have to do properly. If you do properly, on its own, when this goes and it goes, you'll come over there. Then you try to give a small break, you'll be able to acquire. It is as simple as that. But you have to go for a lot more iteration to identify what is the time, to identify what is the velocity, to identify what is the direction. And hundreds of iterations we have done. We arrived at a thing, how we have to do. Which day, what time, amount of velocity. Initially I told now, to Sun, to go to the moon, some number I told. But here you look at here, this talks about if you make an error of 1 centimeter per second, you are away by 6,000 kilometers. That means further you go, your precision in which you have to go is much, much closer. So this has to be taken and you have gone ahead that. So that calls for a lot of iterations, so many simulations we have done. And finally this simulation run, and this is the finally actually also we are driven and go ensure everything is okay, calibrate and do next feed like that we are given. And at this point of time, you give velocity which will go away from the Earth itself and it is acquired by the Sun. So like a Sun's gravity, no additional fuel Earth is expecting, no fuel for the Mars, same as Mongolian. No additional. So it goes around that. This march is nearly 9 months it goes. While going, we something called solar sailing. Okay, if anywhere what you expect versus what you are not there, okay, you have to slightly adjust this. Something called solar wind is there. You can manipulate with that, such that where you want, you are supposed to be there. Which velocity you are supposed to be there, keep correcting it. Almost with free of cost, we reached there. And this time, it's not Dr. Kalam, it is Prime Minister himself standing behind. When we acquired this mission, India has become the first ever country to succeed the first attempt around the Mars. We have done that. Then we told the India how economically we have done like that. Now if you look at here, the whole thing is concerned. Schedule is within the 14 months. We whatever we decided January 2011 to then subsequently are going. Nominally 5 to 7 years will take, but using the existing hardware we are rejigging and doing is concerned, we brought down that. Mass optimization, small launch vehicle, the PSLV itself we can go. Like that we are arrived at there. So that's why elsewhere, whatever amount of money they will spend versus the PSLV, this much money we are sending. Model optimization, whatever we have done. Reuse of hardware and software, because not only that, some of the hardwares we have not done previously. Okay, so-called autonomy, whatever supposed to be done. The first ever time any country has done, we en route to the planetary body, we are keep updating the software. Nobody could have even thought about it. Okay, 9 months are going, 9 months are not also not kept as that. We keep updating such that after reaching Mars, you need autonomy. That autonomy features were keep building in during that time, because within the schedule you should do like that. Many things you have done. Spacecraft costed only 25 million, whereas this is as I told, our Mars moon mission, after that one mission I have launched. Similarly, within the period, because every 26 months an opportunity is coming, every opportunity NASA is sent one satellite. A similar satellite within the 2-3 days of our launch, whatever they launch, that costed $367 million. Okay, our satellite is $25 million. So like that, you look at the whole. Similarly, that satellite, well, to launch it, it costs for $187 million launch vehicle, but we launched with a $20 million launch vehicle. So with that, very many things we have done specific to Indian thing is concerned. Beyond all these things, it has done a branding of PSLV commercially. Okay, commercially, that means with the PSLV, the people can go to the moon or Mars, anything can go, it all like that it came. So that enabled that there. So because of that, today look at here, today India launched more than 500 numbers of foreign satellites using PSLV. So the branding also we were able to bring back. So our original idea of retaining the talent within the organization, attracting the talents from the organization. Before that, we used to get for every year around 200, 300 people you have to recruit. Not more than 1,000 people used to apply. Today, believe me, more than 120,000 people are being applying every 250 seats. I think that is the condition that has happened there. So that original objective also has can come there. Beyond that also many things happen. That the PSLV is one of the finest economically available as a launch vehicle also has come there. So that means not only most economical mission, it has definitely, it has gone much beyond the expectations of that, using a hardware which could have been dumped elsewhere. I think that is another thing. Okay, with Chandrayaan 2, you would have waited for some more time. This hardware, after 7 years of keeping in storage, you cannot launch. That is another issue because making the lander and rover, it came later, 2019 only we launched. You would have waited 2011 to 2019. This hardware would not have been used. After keeping in the ground, you cannot launch it after 7, 8 years there. So that way, you look at here, almost your hardware which is not there also. Taking an opportunity, we are pushed forward. Then you have to work for Chandrayaan 2. Chandrayaan 2 again, same as Chandrayaan 1 or Mission Mangal, but it has gone. But unfortunately, the Chandrayaan 2 landing had a problem. Okay, ups and downs are coming everywhere. So learning from Chandrayaan 2, but still optimizing the mission configuration to save the cost. That means the Chandrayaan 2 lander alone failed, but orbiter is working okay. Okay, that means when the orbiter is working okay within this time frame, you're able to launch next mission. The success chance is better. Even without orbiter, you can do, but you can augment the additional fuel, additional battery sizing, additional hardware strengthening, everything you can do, such that when you are next time when you are landing, your system will be pakka. So that means lessons learned from there, as well as optimizing mission configuration, putting together within the short time frame. Chandrayaan 3 could come. So even though Chandrayaan 2 failed, after that, a couple of missions they made from other countries, even Russia made, but nobody succeeded. Even today, even though came a bit later, Chandrayaan 3 is the first ever system to land on the south pole of the moon. First ever system to land on the south pole of the moon. Because this is the place now people are targeting. Today, the whole world is trying to go back to the moon, to the place called polar regions. But while doing all these things, it's not only 1 or 2 missions. I worked for 60 missions, we told now. And that you look at here, predominantly it is meant for science and technology. Indian space tech takes, when you talk about rocket science, it includes all the things, okay? From mechanical to computer science, all the disciplines are there. So that is basically meant for society. Okay, it's only 1 or 2 missions because when we are serving for society, we are not able to retain the people within the organization. Is a problem. That's why the missions have come. Okay, but for example, today you are sitting, it is a part of your learning. It is not main thing. Okay, similarly, the 2 missions are all like what we are sitting here, but actual bread and butter is to serve the society. Okay, starting from agriculture, logistics, weather, communication, health, navigation, banking, including defense. Okay, today we look at here. The biggest war expected within the 2 days it stopped, thanks to a couple of satellites also. They also serve the purpose where you can have a surgical attack, means where to do surgery, satellites have told. Surgery has been done, but where to do surgery, satellites have told. I think that's happened there. So that means some other form you look at here, every rupee spent in Indian space industry translates to close to rupees of 50 in societal value. Various forms you look at here, people have seen that it has come. In commercial value also, it is slightly more than that is concerned. But beyond that, coming to the individual, I corrected now. The missions also retain the people. So now beyond ISRO, also whatever ISRO has fed me as doing something, just symbolically, not only me, like many people are there. Just I'm symbolically I'm telling. Today, I am not showing much in the space. But what I learned from space, what space has taught me, helping me in various industries, starting from drone, which is being used farm to border. Okay, it's being used now. And agricultural also, waste to wealth. These are all the startups. For example, this is nearly 87 acres. A big factory itself has come and using waste. That means, banana we are cultivating for the fruit. But after that fruit is harvesting, that full stem is going a waste. Okay, in our backyard, whatever is there, we are making use, but nearly India is cultivating so many hundreds of thousands of acres, and those things are going waste, and to even dispose that, farmer is struggling. Now we are able to get multiplying factor of 25 using the stem. After the harvesting, you take the stem and you are trying to process and create a fiber, create an organic nutrient, like that 4 or 5 items, value-added item, such that each stem creates 25 times more than what the banana is going to return to the farmer. Like that, yeah. Similarly, SSI is another thing, probably I will try to do that, where India's first ever surgical robot has been developed, it is being installed also, and working going on. I'm in their board. And similarly, for EV two-wheelers, I'm working for India, made the year. 34,000 rupees on the road, we are able to provide the two-wheeler. Okay, and it is fine-tuned for the farmer, milk vendor, newspaper reader, like that many people get that. Similarly, for STEM education is a part of another NGO activities. I'm here, American India Foundation. Similarly, space startups for a couple of people I'm helping. And beyond that, there was a question, why don't write a book? Actually, to the date, I have written 9 books. Okay, that's also happened to that. And beyond that, I speak also. That is what I'm doing it here. Okay. So this is the bottom line of what all I learned from there is still feeding to me. Okay, that means I retired 6-7 years back, but still I'm connected. Of course, my peers are there. Still I'm connecting. Even for the youngsters, they are mentoring other things. I keep going, and beyond that also, whatever I learned from there, it's keep helping. One such thing I told now, farm to border. Now today, farmers we are able to give this road, and he is able to. The idea here is not only to reach the farmers that we want to encourage the Indian space program, space program. Is it possible to encourage the youngsters to be in the farming itself? Okay, is it possible to create an ecosystem there such that they can do a farming there, so they can implement that? There's no need for that to write the guide. Why can't we directly provide an ecosystem there? I think it's really big way and enabling. So when he is doing here, and he also should not feel shy, that the farmer is also feeling shy, putting their son or daughter back to the farming. They need not feel shy of it. That's right. And we create a nomenclature called agri-doctor. Don't go for running behind need to be a MBBS doctor. You can be agri-doctor, be there from the soil nature finding to which crop you can put, how to do all the things you can do. So this is one thing we are doing. So when I'm doing this for the farming, our idea is post-COVID what's going to happen. We have discussed at the highest level. One of the things what we told is post-COVID, probably the farming industry will suffer. The people will not come back to the farming this way. So it calls for the drones to do here. Same drones can be used in the border when it's called farming. And we are used it. How we used it is the next one. Okay, this is the 2 years back, whatever trial has been done, and the trial has been implemented recently. Detailed video would have seen yesterday what happened in Ukraine. Would have seen that, and nothing but that here. Just you will be able to understand this. What does this mean? That is not a simple drone. Basically, you can hear some kind of an AI constellation maintenance is happening. So like a burst, they will interact with them and they will do their job properly. Okay? They job, go survey a place, what to do, then deliver also. Not only you can deliver. So when such a thing is happening, simultaneously 100 drones can be. Even if enemy hits 50 drones, remaining 50 drones can be damage. And this 100 drones is fraction of the cost of the weapon. And it improves our industry in a particular way. And this is during wartime can be there. Remaining can be performed. Another way. And this is the innovation is India provides a lot of opportunities for innovation. Only keep your mind open. Don't bother in what your age. Just as fun. AI and ecosystem communication are part of the whole. Now the idea here is, in our college, whichever discipline you have studied, it's only how to learn. But when you come to the field, we are totally different way we are learning and doing. And this can continue. This can continue. Yeah, that is just symbolically showing what is the way we are when talk about farm to border. What are the such avenues are possible and how we can do it. And beyond that, you look at here, it may look like different fields, but everywhere the so-called rocket science learn how it helps. That's all I'm putting. So this is the I think robotic system wherein the robotic arm will operate on the patients, and the surgeons is kept here. I am only mimicking a surgeon. I am not a surgeon, but I am telling the surgeons how to use it. That's how it's happening there. So so this is the space enabling telesurgery. Okay, having done that, now we are talking about here just a few meters away, surgeon to the patients. Okay, now we are trying to take it further away. Okay, when you are operating in the rover on the moon, why can't we 100 kilometers, 1000 kilometers away from Super Society Hospital, Narayana Healthcare, to all the way to somewhere in Tumkur or somewhere, Premier Health Center, why cannot we do it? I think that's what we have done it also. Okay, from the of now using our telesurgery using the fiber optic links, it has been done for the good number of various different type of age groups, different type of without any gender discrimination, and we could manage it. I think a good number of things we have done and it's getting qualified. And beyond that, now we are trying to go enable surgeon on the move. That means surgeon can be here, patient can be there, one thing, but surgeon can be on move also, he can be called. Not only engineers can be called to come online. Okay, now medicine also possible, surgeons also possible to go. For that, you have to create an ecosystem there. And to start with, we have done in ecosystem something called like this. Okay, that means in his car, he can fit in and he can connect it to there and he can do it there. And we are now further we are improving upon, okay, with the available VR facilities. That means it in his briefcase it can be there. He can take it and wear and get connected to the 5 satellite wherever he is. Okay, this is another innovative approach we are trying to take it up here. So whatever the precision I told, whatever the engineering things, whatever I told in our Chandrayaan, Mangalyaan, doesn't mean just stop there. It can come here. Idea is it can come such a things, either the farming or healthcare, education, you name it. Imagination is the only limit. Okay, how you can apply is up to you. I think so much possible. Basically, just indicating possibilities are huge. Okay, and the possibilities, when you are unraveling the possibility, your longevity also long. Okay, that is also another because you have to live long. Without living, you cannot live long. Okay, that means the life to make it there. So that means we would have studied. Actually, somebody from GCT also here, PhD also here among the group. So I done my PG here, I done my UG here, and the PhD at Anna University. So we would have learned our hard skills and soft skills, to some extent our global soft skills also. But that alone is not good enough today. Look at here, lifelong learning. Okay, lifelong learning is the real bottom, not only bottom line, it is the heart line. Okay, to me, I am, for example, today when I'm talking with you, even to make the view graphs, I have to learn slightly more than what is known yesterday. Okay, with yesterday's skills, I can be starting here today. If I don't learn today here, tomorrow I cannot stand such a place here. I know about that. So it's lifelong learning is the bottom line of that. I am really happy that DC University is taking that role within the Siemens. And I think you definitely, it is both the hands. They are giving the facility, making use, definitely it can take you a long, really long. Okay, because you keep your faculty engaged, that will make you young. This is my personal experience. Okay, thank you very much.
We have another 10 more minutes left. If you have any questions, we can take it now. Anyone here with questions? Yeah.
Hello, sir. I'm Nilofanisha. I'm from Tamil Nadu. It's a real privilege to have you here, sir. It was a magical moment to me because I am a science lover as well. It took me back to the days, to my 12th standard days, where I'm sitting in one of the finest physics class with the finest physics teacher in front of me with practical experiences. Thank you so much. I have a lot of questions in me, but yeah, I would like to ask this to you. What do you have to say to the students who are looking to pursue a career with space science? How welcoming ISRO is in terms of environment, culture, also remuneration also for that matter. And also if you can take us through the route to get to ISRO. You know, if you wanted to become a doctor, the route is quite clear. If you wanted to become an engineer, again, the route is quite clear. I feel that this awareness is not there in among most of them. So yeah, your insights in this area. Thank you.
Okay, one of my mission is also to make the people aware of what such thing is there. So thanks for that question. But now you look at here, pretty straight, the physics line, if we are doing it, definitely every year we have our own entrance exam people can do. And even before that, if the +2 you have done well, and your IIT and the JEE entrance exam you have done well, and we have our own university, deemed university, Indian Institute of Space Science and Technology. You can apply for that. If you get a position there, your job to ISRO is almost guaranteed. That means with 75% you are able to get through the 4-year course. We have science and as well engineering, 2 streams are there. Any one of them you get through that. After the 4th year, ISRO asks, are you ready to join ISRO? If you're ready to join ISRO, you can join. That opportunity is right away sitting there. Or else after BE, you can apply. After post-graduation, you can apply. After PhD, you can apply. So various things are available. Earliest opportunity is after +2 is possible. But now if you want to apply with the additional qualification, now the people ask for example, if you're working for image processing, NRSC request for that. Now, beyond all these things, now space is open to private industry. So Indian space program is no longer under the four walls of ISRO. Outside also many good number of organizations have come, and there also possibility exists. So that way Indian space program is opened up in a big way.
Thank you, sir. Thank you. One another question. I couldn't refrain myself from asking this question. Do we really have aliens? Do we have any reported evidence?
I cannot tell either no or yes. Okay, to tell no, we have not seen the whole moon. For example, moon is there. Everybody told moon it doesn't have water. But when we went through the whole moon, when we have seen only, we could see the pockets in which water is there. Similarly, the whole universe we have not explored. Without exploring, it's not possible to tell. But without seeing, we cannot tell yes. So neither yes or no.
Thank you. Thank you so much.
We have time for one more question. Anyone here would like to ask a question?
My name is Jainam, and I will come to question straightforward that what step ISRO is taking towards quantum communication?
Okay, quantum communication point of view, ISRO provides the platform. Okay, and ISRO also there is a wing. It's working for the quantum communication already. For the few kilometers, testing is done, and with the RRI, Raman Research Institute, people are working. You know that, and there we are trying to see the possible platform by satellites. Okay, that is there. But otherwise, ISRO enables this sort of things to go, because secure and safe communication is the real need of the hour. And China has already gone ahead. We cannot lag behind. So towards that, it's happening. But yes, of now, from the lab coming to the space, ISRO provides the platform. And initial tests we have done for the few kilometers is concerned.
Thank you. So one more question, which there's one online, I'll just ask that. Thank you for the insightful session. At your level of leadership, how did you approach and handle failures, especially in the context of space missions, where a failure not only implies a significant financial impact, but also touches the pride and aspirations of the entire nation?
For the failure, how to? Yeah, now you look at here, this particular the domain, we like exploration. Okay, the Everest when you're climbing, you are not sure. You would have gone to the top also, from the top to coming back also, anything can happen. So this is the game in which anything can happen. You should be ready for that. But notwithstanding that, not to fail. That's whatever I told here, not to fail. We are trying to see today's technology is concerned, how you can simulate as much as possible all the failure conditions, how you can be equipped with in case that's happened. So this is the lot of iteration we'll go through, lot of the tests and other that are going through, such that not to happen. But in case it happens also, that's another thing I used to tell that. So I used to tell that, for example, I used to sell my grandson. He's asking for ice cream, but ice cream is not given, you give chocolate. Don't worry, ice cream is not, you have not given ice cream, you take the chocolate and do that like that. Okay, that means something what you expect not getting, you take as a disappointment or setback and try to look for something else. So even if some failure, it could have been look at failure, don't accept the failure, accept it as a failure at the first cut, try to get back. You have fallen, doesn't mean you cannot get up, you have to get up. So you have to get it up like that. So like that, I have an innumerable amount of stories. Out of 60 satellites, at least I can give 50 examples where not all 60 succeeded at the first attempt. There are many failures. Not failure, many not unexpected way. But we overcome that thing and made it to circumvent the problem and made it to every satellite to live its life. So that is the way nominally we will do. So that's why I used to tell that even Chandrayaan 2, at my hindsight, somehow we would have revived. Even today, I feel somehow we would have revived, somehow we missed it. But for that, I think there are so many ways. Actually, Indian space program is known more than finding a water on the moon, going the Mars in the first attempt. Indian space program is known. These people never use the mission as it is, abandon the mission and come back. Somehow they regroup and get back. I think our reputation is more in our professional program. So nominally, such a satellite, for example, satellite, one solar panel not working, they used to abandon the mission. We never used to like that. Okay, somehow our scooter not working, somehow we know how to make it work. Correct? Na? That is the spirit ours. Similarly, our satellite, even if it's on Condor, some issues are there, we used to overcome and do that. Actually, our reputation is more on that. Actually, I am known for that. Rather than that is one of the reasons why Chandrayaan and Mangalyaan, I was made a project director, even beyond engineering skills. So I think that is a part and parcel of our missions. But nowadays, some failures are coming. Then we can overcome that.
Thank you so much, sir. A big round of applause to your wonderful and educational session, sir. Thank you so much.
Thank you. Thank you.
I just request Kala, the head of development center, to close the.
Sir, I'm spellbound,
Oh.
and I'm honored to be standing next to you here.
Oh, thank you.
And thanks for this opportunity, by the way. Thanks for taking time out of your busy schedule to come and address us. I noted down many things, actually. This is the demonstration of the true leadership, right? It is about never give up attitude, standing for the purpose, because especially when you are deep into the mission and when there is a change expected, that is where leadership means a lot. And it's not about just taking the decision for yourself. It is taking the decision for the nation. Right? That is the weight that he was carrying. And for me, it felt like I'm sitting in a thriller movie and how it should be. Just listening to this, I had goosebumps. How will it be for him when he is in the midst of so much of ambiguity, failure looking at him? All the nations who have tried something similar to Mangalyaan have failed multiple attempts, 30 attempts. And here is the man who is standing here, makes a decision and takes his team along and gets it right the first time. I have no words to express the leadership and the respect that we have for you, sir.
Thank you.
So this is something that we have to take back, right? As leaders and as life will throw many things at us. So how would you believe in yourself? And how do you take that weight that whatever you do is going to impact multiple lives? In our case, we are in healthcare. And I was wondering, as you were telling your stories, I was wondering, oh, you can apply this in healthcare, right? Yeah. Because knowledge teaches you power. It brings power in you. But experience teaches you possibilities, right? So this is where, as he was explaining, how can he use the same technology in a different domain? And especially if you look at the whole healthcare, right? We tell the stories. Our narrative starts with at least 50% of the whole world does not have access to basic healthcare, right? So especially if you look at India, okay, there's a huge difference between rural and urban. So through the telehealth and then teleradiology, through technology, you're looking at how can you increase the possibilities. So today, as I sat there for the last 1 hour, right? You made me think of possibilities wherein DC can make a huge difference to access to healthcare, because this is like mini Siemens Healthineers, because we have all the businesses together. And this is where we have the power. I tell everybody, don't look at only your business, right? When you think about human body, it is not only one organ. It is multiple things. We talk about interoperability. It is about what happens in our body. So look at possibilities where you can remove that silos. That's the lesson I learned from his experience sharing in the last 1 hour. How can we remove that silos? And how can we look left and right? Because we are known for jugaad, right? That's what you talked about. And how can you improve the possibilities and make the impossible possible? So you talked about the teamwork, the courage, the adaptability, and how can you leverage technology to make impossible possible? And especially, you talked about satellites and then the precision. Yeah. But finally, what matters is the human mind and the humility and meaningful innovation, which has a purpose. So with this, I truly want to thank you. And let us take a note of the lessons learned and make DC much more stronger by de-siloing. That is my request to all of you. And we can go back and tell him, how did we make things possible for the whole humanity? Yeah, thank you, sir.
Thank you. Oh, thank you. Thank you. Thank you.